Hello everyone. So welcome to another Leetcode question. And this question we are asked to convert a Roman number to integer. The Roman number is given to us in a string format and we have to return the integer. Okay, so this is the input. Let's go through a few examples to understand what is expected out of us. So in this example, we have given III. Okay, and we have been given a table. In the table, from table we can see that this symbol I carries a value of 1, V carries a value of 5, X carries a value of 10, L carries a value of 50, C carries a value of 100, and D carries a value of 500, and M carries a value of 1000. There's one important thing that we have to see here is that Roman numbers are usually written largest to smallest from left to right. Okay, Roman numbers are usually written largest to smallest from left to right. So a number at the left index should be largest than the number next to it, okay, or equal to it. Let's see how we can compute the value of this Roman numeral in integer. This is x carries a value of 10. This is x carries a value of 10. This is v carries a value of 5. And 1 carries a value of 1 each. So if we sum this number, we will get 10, 10, 20, 25 and 2, 27. So the output of this example would be 27. However, you can say that if we have to represent a number 4 in Roman numeral, we can write it like this. But no, it doesn't work like that. What we have to do, we can write 1 then followed by a v. I followed by a v. I carries a value of 1 and v carries a value of 5. In this case, from left to right, it's actually happening the reverse. It is small first and then the large. So in such a case, what we can do, we can subtract the small value from the larger. Okay, so let's see in this example what's happening. We have 1 followed by a x. So 1 carry I followed by a x. I carries a value of 1 and x carries a value of 10. Now we know this is not following the standard where in Roman numeral we write from largest to smallest. Here it's smallest to largest. In such a case, what we do, large minus smaller. Large is 10 and small is 1. So we subtract, we get 10 minus 1 is equal to 9. Okay. However, it has also been given to us there are only few instances when this occurs. Let's see what are those cases. If we have an I followed by a V, the value of that Roman numeral would be 4. If we have an I followed by a X, the value of that Roman numeral would be 9. Similarly for X and L, X is 10, L is 50. In that case, the value would be 40. If we have X and C, X is 10 and then we have a large value. So in this case, the output will be 90. Okay, basically large minus small. Okay, now here what would be the value of CD? C is 100, D is 500. And then again, this is the case where we have a small followed by a large. So what we'll do, large minus small. So 500 minus 100. What we'll get? We'll get 400. Similarly for CM, it will be small and then followed by a large. Okay, so large minus small, 1000 minus 100. We get 900. Okay, now if we have got this thing out of picture, let's see how would we compute the value of this in string. Okay, so we have first value as first character in Roman numeral as M, and then we can check whether the next character is greater than M or not. In this case, C is not greater than M. Okay, so we can just take M, the value of M will be 1000. Now when we come here for C and M, we see that first we have a small value and then a large value. So every time wherever we are, we should take into consideration the current character and the next character in hand. In this case, if we take the first character and the second character, CM is actually, if we look above in this map, this is one of those instances where we have to subtract the value and then add it to the final result. So CM will become 900. Okay, similarly for XC, and then we move our indexes by 2. So index was initially here, then we reach here, now we'll jump by 2 and we'll come here. In this case, again XC falls into one of those cases, right? XC value is 90. So we take the 90 value and jump our index by 2. So now our index is here. Okay. Again for I and V, we will have a value of 4. This again falls into our this case. Okay. So IV is 4 and we add it to our sum. So final result we will get is 1994. The intuition, the brute force solution and the optimized solution is pretty much the same. In such questions, most of the things are given to us in how we interpret the question. This question was quite straightforward, and given the inputs, the examples and the solution answers, we can easily come up with a solution. So how we'll do this? What we did is initially we created a map out of it, right? So we can create a map like that, where we have the already symbols till M, and we put that symbol with the value in the map. So we have symbol and then the value in the map. And then for other 6 symbols, 6 instances that we saw, for that also we have put those values in our map. Okay. Now we'll start from here. What we have is I is initially pointing to 0. Okay. So can we take the next character and make a digit out of it and look in the map? In this case, yes, we can. So if we take MC, and MC, if we see, it doesn't exist in the map, right? MC doesn't exist in the map. So we can simply take the value of M from the map and add it to our sum. So our sum will become M is 1000. So we'll add 1000 to it. Now we increment our index I by 1. Now we see, can we take 2 characters at a time and check in the map if it exists? So now let's say CM is the case. For CM, we have a value of 900. So yes, it exists in our map. So we'll add it to our sum. Now my sum will become 1900. Now since we have taken 2 digits from the string, we will increase our I by 2. Now we are X. Can we take another character to see if this 2 digit exists in our map? XC, yes, XC exists in our map. So from in sum, we will add 90 to it. So it will become 1990 and our I will increment by 2. Okay. Now for I, we'll see if we can take 2 characters for our string or for our digit, if it is in the map or not. 15, yes, it's there in the map. So we'll take the value from map and add it to our sum. So my sum will become 1994. And since we have consumed both the digits, both the characters of the Roman numeral, we will increment I by 2. Now we have exhausted all the characters of the Roman numeral. We can return this particular sum. So this concludes our algorithm. Let's see the time complexity and place complexity for this. The time complexity, as we see, Ri, the index, goes from first character to the end, all the characters. It has to explore all the characters of the string. Therefore, n is actually the length of the Roman numeral. Time complexity will also be linear to the length of the string. However, in our algorithm, we didn't create any auxiliary space in between. We only had one sum variable and an index variable, right? So our space complexity will be constant and time complexity will be linear to the length of the Roman numeral string. Okay. So let's now go to the code walkthrough. What we did is we initially created a map, the map that we saw above with the 13 instances, this map. This was our map. We created a map like that. We initialized 2 variables, I and a sum. And then we explored till the end of the length of the string. But we wanted to test if we can take 2 characters at a time from the Roman numeral string and check if it exists in a map or not. So it will only be possible if I is less than 1 deducted from the length of the string, right? So if we have, like, let's say we have 4 characters and 0, 1, 2 and 3. This is our Roman numeral and there are some values here. If my I is here, So basically it means I can take these two character and explore it on a map, right? So I is 2 and 2 is less than s dot length minus 1. S dot length is 4 minus 1, which is 3. So in this case I can take it. But if my I reaches here, 3 is less than 4 minus 1. Is it true? No. So in this case we won't explore the two digits from the Roman numeral at a time. Okay. So this certainly helps in that condition where we take two characters and explore it from our map. Now, if we have a digit constructed as string from the character at index I in string s and character at index I plus 1 in string s. Okay, so we make a digit out of it and we see if our map has a digit or not. If the map has that digit, we'll take the value out of the map and add it to our sum. And then we increase our index by 2 and then we continue. So in this case, we will then go here and we'll continue. Otherwise, if it doesn't happen, if map doesn't have the digit, then what we can do, we can just take the value of that digit from map at index I and add it to our sum. And then we'll increase our index by 1. Okay. So at the moment we come out of this loop, we are filling the sum. We'll filling the sum in the sum variable, and finally we can return our sum. Okay. So this concludes our code walkthrough and the problem Roman numeral to integer. Thank you.